Okay, I'm gonna talk about the questions you sent me. Uh, your answers overall good, but there are few technical things that you're missing, and I know from experience that professors look for those small things. So, for instance, question number one, uh, you calculated the percentages for drinking students for each university. Percentages are right, so you have no problem with that. So yeah, for University A it was 14%, for B 17 and 26. I'll use the darker if I can find it. Yeah, maybe it's one. Okay. But you say there is no dependency. So whether they depend on each other or they don't depend on each other, don't answer the question right away. Percentages sometimes are misleading. So we need to know if they depend on each other or if they're independent of each other. If they depend on each other, that means that they're the same. The three universities, the drinking would be the same here. Independent means that the drinking is different. Don't answer the question, leave it till you do the hypothesis. So when we went to B, you said, what kind of test? You said homogeneous. There are three populations, A, B, C, one categorical variable, perfect. And C, they wanted you to define H0 and HA. Here you missed a key word. Now, in defining them, if you refer to the chapter, you have to say this for homogeneous. You have to say the distribution of drinking, which is the variable name, the categorical variable, is the same for the three populations, University A, B, and C, and HA would be not the same. This is how we write the hypothesis when it's homogeneous. If it was independent, for instance, the other type, you would have two categories. You would have a variable 1 versus variable 2. So in H0, you would say variable 1 and variable 2 are independent or not associated for the population of whatever the sample is. And HA would be not independent associated. So remember keywords, like in your answer you said right away population of university is the same. It's never the population. It's the distribution of the variables. So make sure that you write this in the defining the H0 HA. Okay. Then they wanted you to find the p-value from Minitab. So p-value from Minitab, you found it. It's 0.079. and degree freedom also from Minitab 2. And if it's not given, then it's rows minus 1 times columns minus 1. In terms of rows, you have drinking, not drinking. Columns, you have University A, University B, University C. And if you do the math, it's 2, but you also see it in the output. They also want you to do it using the table. In the same exam, if you scroll to the end, page number 12, at the bottom of the page, they give you the Chi table. If you go to degree freedom 2, you'll see your number in Minitab for the test of Chi. It was given in Minitab next to the p-value. It was 5.068. And this line, 5.068, is between 4.61, 599. So when they say the numbers from the table, you're between these two. And for p-value, if you go up, that would show these two numbers are between 5% and 10%. Good? Okay. And then the question was to assess the significance. You said it's insignificant, do not reject, do not conclude, which is right, because p-value was more than alpha. And then we choose option C, cannot conclude that the distribution differ. Good. But now you can answer the first question. So in your conclusion, after you make the conclusion, you can answer the dependency question. In your conclusion, you say, we cannot conclude they're different. Meaning, they're not, we cannot say they're different, they mean that they're the same. And if they're the same, then they depend on each other. So in your conclusion, you say we cannot conclude they're different, meaning we can't say they're different, they're actually the same. And if they're the same, remember, same, that means they depend on each other. So your answer for A was supposed to be they depend on each other. Okay. And then they ask for the condition of expected cell frequency. You had it right. Expected cell frequency condition means that all expected values must be at least 5, and in your case it's satisfied since minimum expected value is 81. Yeah, I forgot about that they wanted you to calculate those two missing numbers. Now, if you look at the Minitab, you see University A, B, C, here drinking, here you have not drinking, here you have, say, 14, 19, no, I'm looking at the long, minimum is 19 here. So 14, 19, 1.316, you have 3 numbers here, you have 3 numbers here, In the nut, you have 86, you're missing a number. Here, for instance, you have 83, 81, 49. Here we have 74, 81, 605. And you have total. Here you have 100, 100. Drinking, you have 57. Not drinking, 243. The entire sample is 300. And in this table, the structure is, where you see the four numbers, the first number is the observed number. The second number is the expected number. And then you have the chi. So in all of them, the three numbers, observed, expected, chi. Observed, expected, chi. That's why I said the minimum expected is 19, because the second number is 19, 19, 19, 81, 81. So the minimum in all of this, the minimum expected was 19. To calculate the expected here and the chi here, you need the expected for University A and not drinking. To do this expected A, not drinking, you take the total A, which is 100, times the total of not drinking. So you take the total of the first group, the total of the second group, and you divide this by the entire total of the system. So total group 1 times total group 2 over the grand total of the system, and this gives you 81 eventually. And to do the chi is usually observed minus expected squared over expected. So you take so now we know it's 81. To do the chi, which is the number under this, you take the difference between them, the observed and the expected, because this is observed, this is expected. You square this and you divide by the expected. So the difference squared over expected. I did this, and I believe it was, I don't know if I wrote it. But you do this in your calculator, it would be 5 squared over 81. So that's the answer for the first question. For question 2, you say, by looking, discuss the equal variances. You explained this perfectly. Looking at the dot, the vertical distance seems the first condition met, perfect. And the insert the line. I don't know if you did this, but to insert the line, this is A, B, C. They tell you in the table that the sample mean of A is 71. So you look for where 71 is, and I believe it was like here. So this would be where 71 is. The average or the mean for this one is 79 or almost 80. So let's say this is 79 or 80, so it would be somewhere here. And the average for this one is about 73. Which is a little bit above the 71, so you're supposed to connect them by a line. Now, in the next question, fill in the blank. You did it perfectly. you calculated all of them all the way to the F value, and the p-value was given, and it was 0.002. You did this perfectly. Then report the test and the p-value. This is the test and p-value. Give the conclusion. Oh, state the hypothesis first. In stating the hypothesis, now read the question in terms of the population and define what mu1 is. So you said mu1 equals mu2, mu3, at least one is different. But again, it seems like you have a problem with defining, and like anything involving words for defining, or so you said mu1 is the population test score. No, the mu, anytime you define mu, you have to mention the word mean. So you can't just say population. No, it's mu1, the population mean of test score for all 6th grade students in district. So you have to say population mean of whatever in the question for all, whatever the sample is. But you have to say the word mean when you define mu. So we keep going. Benferroni, you're not responsible, so don't worry about G. You don't need to know it. It used to be part of the course. And now, given the intervals, discuss if they're different or not. I don't know if you remember this from before, but I explained this when I said, you remember when you have negative, negative, positive, positive, negative, positive, and I said when you have negative, negative, they mean they're different, since 0 is not within confidence interval. And negative positive means not different, since 0 is within confidence interval. So for instance, if you look at A and B, they tell you negative 14, negative 2. So AB, negative, negative, they're different. AC, you'll see negative, positive, so not different. And BC, you see negative, positive, also not different. And when you explain, you say this. The first one is different since you have 2 negative numbers and 0 is not within. These two are not different since we have a negative, positive, and 0 is within. Okay, question 3. The two-factor ANOVA has no interaction term. Explain why that's appropriate. I don't think you answered this. Yeah. Looking at the graph for question 3, do you see the lines crossing each other, intersecting each other, or they're separated? You say it is appropriate the lines are almost parallel to each other and do not intersect. If they intersect, it would be obvious. It would be something like this, and then you would say it's not appropriate. They give you the table, the ANOVA table, and at 10% alpha, they ask for the education level. I really like the way you, because you explained this in full. You said education level has no effect on the population mean, so you use the word mean, of annual income following the gender for the population of all samples, and these, I don't know why you use the word slope, and these gender, male and female, and for the high school university degree, which is apparently there are 3 levels for university degree: high school, university, and so you needed to define. First of all, you don't need the word for these slopes. You say for this gender, male and female, and for the degree or for education, and you name them. You did that. The high school, university degree, high school, university, and advanced. And you remember the word mean. That's the most important thing. So you state the hypothesis, but you didn't continue with the question. I don't know why. After this, they wanted the test and the p-value. For education, since it's education, so you pick the F for education, which is 44, and the p-value for education is 0.00. Strength, it's very strong because this is less than the 0.01. Very strong evidence to support HA. In terms of significance, it is significant. That's 0.00 is less than alpha. Reject and conclude HA. So you're concluding HA. What type error? They could ask for this. Remember, when your conclusion is to reject H0, type 1 error could be committed. If your conclusion do not reject, that's type 2. So that's if they ask the question what type error could be committed. Question 4 was for single regression. So you had the equation right. So it's 13 plus 5284 or 8 of age, perfect. It was given in the Minitab, obviously. Use it for woman number 2. So you looked at the table. Woman number 2 is 21 years old. You plugged it in the equation. You got a waist of 24.088, perfect. Residual is the actual minus predicted. You did that right. And state the confidence interval. So you said it's 23 and 28, perfect. But you didn't explain what it means. To explain a confidence interval in regression, you say, well, if assumptions hold or since assumptions hold, we are 95% confident that mean of whatever the y is, which is waist, and it was measured in inches, is for all because this confidence interval was specifically for women age 21. In fact, you see it in Minitab, they tell you, no, actually, it's for women 25. Let me see, yeah, it's for women 25. For all women 25, they say this after, you say, values predicted for the observation 25. For all women with age 25 is between, and you put the two values in the confidence interval, 23 inches. And in the last video, at the end of the video, or last part of last video, I explained the confidence interval, same idea for this, and for the prediction. So if you ask for prediction, we predict with 95% confidence that the actual waist in inches for randomly selected woman age 25 is between, and the prediction is 16,994 and 35. And to calculate confidence interval slope, they always ask for the confidence interval slope. They usually ask to be calculated. So, you know, slope is the coefficient next to age. 5284. And in Minitab, next to it, you see the SE of 1195. Confidence interval, B1 plus or minus T star, the SE of B1. This number, 5284. This number is 1195. We need a T star. It's 95% confidence, degree freedom for single regression like this one, it's n minus 2. And the degree freedom for multiple regression, which is the last chapter, it's n minus k minus 1, and I told you k would be number of x's. It's pretty much the same, but for single regression, if you think about it, k is always 1. So -1 is -2. So we just say n minus 2 for single regression. So if you go to the t-table provided, for degree freedom, we have 20 women, minus 2, 18, and 95. Your T number is 2.101. So you multiply these two and then you add a minus, you get two numbers. And I also in my video, the last video, and I interpreted what this means. The confidence interval for slope. So we are 95% confident that as x, which is age, increases by 1 unit, the waist of women will increase between these two numbers for all women in the population. R squared, and interpret what it means. The interpretation for R squared, perfect variations, not perfect, I'll talk about. First of all, they wanted you to calculate it. This is, it wasn't in the assignments. It's kind of new here. And to calculate R squared, you go back to the Minitab. You see there's something called analysis of variance. You take R squared, you take SS regression over SS total. Not a very famous equation, but that's how you calculate it from Minitab. Your SS regression is 344, and the total is 66.8. I'll use a calculator in this phone. Three, 66 over 661.8. That would be 5208, or about 52.08%. So you say 52.08% of the variations in Y can be explained by X. But instead of Y, you say waste, and instead of X, you say H. You don't put both of them together. But if it was multiple regression, because this question was for the single regression, maybe I'm jumping ahead of time, but in the single regression, they wanted you to find it and not explain. But if you're to find it, I told you take SS regression over SS total, and it was 52% roughly. So 52% of variation of Y can be explained by X. And 52% can be explained. So if they ask you the question, what percentage of variation cannot be explained, would be the remaining, which is about 48%. So be very careful when you read the question. Question 5. The first part, this is multiple regression. State the hypothesis and define the parameter. You notice in the question that it was about the combination, perfect. But you wrote the hypothesis wrong. Look how I defined the hypothesis when it's combination. We don't say mu1, mu2, mu3 when it's combination. For a combination, we say there is no effect of one of the factor or combination on the waste. So no effect. So we do it in effect language. So H0 would be there is no effect, HA would be effect. We don't do mu1, mu2 for hypothesis testing combination. But you notice that it's combination, so you pick the F, the right F from the table, and you pick the right p-value. Perfect. P-value was definitely less than 5%, so reject H0, conclude HA, and you interpret the R squared value. R squared value, if you refer, it's, again, you go back to Minitab. I don't know why you said 95%. If you go to the Minitab, R squared was 52.4. So R squared is 52.4% given in Minitab. And the way you explain this, 52.4 of variation in Y can be explained, but since this is multiple, you say by X's. So 52.4 variation of waste can be explained by age and height. You didn't mention Y at all, and you said 95. You probably confused it with the confidence interval percentage. No, it's the R squared percentage they're referring to. significant, interpret, prediction. The prediction, as I said, according to the Minitab, it was for age 25 and 60. So to interpret this, again, if assumptions or since assumptions hold, whatever, we can predict with 95% confidence that actual waste for a randomly selected woman with age 25 years and height 60 inches will be between, and you put the two numbers. And the two numbers for the prediction are 16 and 35. And what's the p-value for waste only? What can you conclude? Since they ask for a certain one of them, so you go to the table, height is 0.33, p-value 747 for the height, so that would be more than 5%, so do not reject. Meaning H0, there is no effect. This test is good. Obviously, from the first page, you can see that it was designed by Nelson. But when they did this in that semester, there was no emphasis on assumptions. So you still need to know the assumptions. So what I would recommend, all the long questions would be based on week 4 to 8. You're not going to see anything like long question for stuff before. So I want you to watch the 4-8 and make sure, create a template of how you can define the parameters, state the hypothesis, and highlight the words that you change. Like they all have, say, the word mean, but the mean of what, that's in the question. Sample of what, so make that, because there is a lot of focus on this, plus the assumptions. So you need to watch the 4 videos of 4, 5, 6, 7, and 8. I don't know if you even need to do 4. It's the chi-square after. Anything chi-square after. Maybe 5, 6, 7, 8. And again, this is a good question, except there is no emphasis on, the assumptions. Now, what I'm going to do, I'm not going to do another video. What I'm going to do, I'm going to look at the short answers tonight, and I'm going to talk about them and give you how, like, keywords or how you can find the answers. And that's about it. And for the cost of what I did previously, or how much you owe me, I'll write it down, I'll text you. And if you have any questions, of course, don't hesitate. Good luck.